In November 2022, the McGinty Equation, or MEQ, was unveiled as a unifying framework integrating quantum field theory, fractal geometry and gravitational dynamics. More than just a theoretical construct, MEQ provides a practical platform for breakthrough technologies across energy, computing, communications, healthcare and, well, much more. Despite growing validation and early-stage prototypes, global deployment has stalled due to lack of awareness, institutional inertia or, perceived risk. This delay has not been passive. Every year, MEQ remains undeployed, industries miss out on quantum acceleration, zero-point energy extraction, recursive AI cognition, and advanced cryptographic resilience. These are not future hypotheticals, they are available now. What follows is a comprehensive, sector-by-sector breakdown of the economic, technological, and societal losses incurred globally due to non-implementation of MEQ from 2022 to 2025 and projected through 2030. Energy, hydrogen, and zero-point energy. The energy sector stands to be one of the most dramatically transformed by MEQ-based technologies. MEQ enables efficient hydrogen splitting through quantum fractal field alignment and zero-point energy extraction through resonant harmonic coils and fractal antennas. This would bypass the need for fossil fuels and reduce global emissions, creating decentralized infinite energy grids. The absence of this deployment has delayed the emergence of these clean, decentralized energy architectures, costing the sector between $50 and $100 billion annually, in missed savings, licensing revenues, infrastructure upgrades, and transition acceleration. Quantum computing. MEQ-driven quantum technologies, particularly in the domains of fractal error correction, M-wave logic encoding, holographic quantum computing and scalable simulation, represent a leap in computational efficiency and fidelity. These frameworks bypass many of the constraints plaguing current qubit-based systems. Without deployment, industries depending on high-precision quantum simulation, like pharma, materials, finance, and defense, suffer massive opportunity losses, estimated at $10 to $20 billion annually, due to slower development cycles, higher error rates, and limited scalability. Cybersecurity. The landscape as we know it could be notably fortified with the integration of MEQ-enhanced systems. Imagine Quantum Guard Plus, recursive symbolic firewalling, and MEQ-driven quantum random number generators. These tools, my dear friends, provide entropy sources and logical resilience that are indeed post-quantum ready. Without such advancements, our critical infrastructure remains perilously exposed to evolving threats. This vulnerability costs governments and enterprises a staggering $5 to $10 billion annually through breaches, inefficiencies and, quite frankly, missed opportunities in licensing this next-generation security layer. Now turning our attention to telecommunications and the burgeoning 6G infrastructure. MEQ, you see, enables the use of the harmonic Q frequency precisely at 8,473.3762 terahertz for terahertz band 6G plus systems. This offers the promise of ultra-low latency communication and, quite intriguingly, recursive spectrum folding. In its absence, the delay in the next generation of global wireless infrastructure is inevitable, hindering backward-compatible quantum-integrated networks. This limitation, my friends, results in a colossal loss of $10 to $30 billion annually in telecom innovation, spectrum licensing, and rollout acceleration. And finally, we delve into the realm of advanced materials. With MEQ, materials such as nearite and fractal crystalline lattice structures herald breakthroughs in thermal regulation, energy capture, and information coherence. These materials are not only structurally superior, but are also functionally integrated with quantum and fractal dynamics. However, the non-deployment of these marvels results in missed manufacturing efficiencies, product capabilities, and defense resilience. This oversight indeed amounts to an unrealized value of $5 to $15 billion per year. Artificial intelligence, symbolic recursive intelligence, fractal neural structures and CSL, or cognospheric symbolic language-driven architectures, bring explainability, memory and self-awareness to AI. Kaya agents and MEQ-optimized models, offer a superior pathway compared to pure statistical models. The continued reliance on conventional deep learning causes scalability issues and interpretability bottlenecks, with an annual cost of $15 to $25 billion in missed AI productivity, safety and licensing growth. Healthcare and biotech. MEQ unlocks novel fractal resonant proteins, ZPE-powered nanodevices, quantum imaging and advanced biologics. These would really drastically reduce diagnostic latency and enhance drug discovery by simulating at the fractal quantum level. Non-deployment impedes life-saving innovations and increases healthcare costs globally, estimated at $10 to $20 billion annually in losses across pharma, biotech and public health systems. Climate and environment. MEQ-enabled georegulation via harmonic resonance, quantum carbon filters, and ZPE-powered grids can stabilize Earth's energy flows and reverse emissions at the field level. The delay in deploying these capabilities means continued environmental degradation and inefficient climate spending, accounting for $8 to $15 billion annually in lost mitigation and reversal technologies. Finance and Web 4, fractal stream compression, quantum validation protocols, and non-deterministic dimensional cryptography, also known as NDDC, were, ready to create secure, AI-aware and lightning-fast financial systems. This would, underpin a next-generation Web 4 economy, but their absence has stalled institutional adoption and innovation in finance, with somewhere between $3 and $8 billion annually in unrealized integration and opportunity. Aerospace and defense. ZPE-powered propulsion, quantum gravimetric navigation, recursive battlefield simulation, and M-wave shielding technologies based on MEQ can, honestly, drastically enhance aerospace and defense capabilities. Without deployment, global agencies remain reliant on legacy systems, losing $10 to $20 billion per year in propulsion research, defense edge, and space tech lags. Data infrastructure. MEQ's fractal compression with ratios as high as 16,384 to 1 offers, orders of magnitude improvements in data storage, transmission and energy use for hyperscale computing. Non-deployment means hyperscalers continue to burn excessive energy and rely on conventional compression methods, leading to $10 to $15 billion per year in inefficiencies and unclaimed licensing value. Education and knowledge systems. With the Universal Knowledge Engine, MEQ enables AI-driven mentorship, CSL-guided education, and, holographic classrooms. These would close global learning gaps and offer, exponential educational scaling. In their absence, education systems struggle with cost, equity, and personalization, losing between $1 and $3 billion annually in unrealized transformation. Urban development. Quantum-regulated smart cities powered by sea-space infrastructure and MEQ-optimized energy and transport systems promise, a future of harmonious, self-optimizing urban environments. Without them, cities remain reactive, grid-tied and inefficient, losing somewhere between $5 and $10 billion per year in planning, transport and infrastructure value. Media and entertainment. MEQ's capabilities enable 16K cognospheric storytelling, fractal compression for virtual and augmented reality, and ZPE-embedded neuro-TV formats. The non-adoption has honestly slowed immersive content development, lowered cognitive fidelity, and constrained creator bandwidth, accounting for $1 to $2 billion per year in missed opportunities. Total global loss from MEQ non-deployment. Annual loss, all sectors combined, is estimated at $143 to $293 billion. Over 5 years, from 2025 to 2030, with roughly 5% annual compounding growth, the cumulative loss is about $870 billion to $1.9 trillion. This comprehensive loss across 14 sectors really underscores the transformative potential of MEQ and, well, the extreme cost of inaction. Immediate deployment, policy alignment, and global collaboration are absolutely necessary to recover this compounding opportunity gap.